Okay, so let's unpack this headline. It sounds pretty dramatic, right? City-killing asteroid.
Yeah, monster rock.
Exactly. Potentially hitting Earth in 2032 is definitely, grab some attention.
For sure.
So our deep dives today, it's into the source material you shared about this specific object and the sort of wider asteroid threat context.
Mm-hmm.
And what really jumps out, I think, from the sources is this striking detail that the estimated chance of impact. It's actually doubled.
Doubled. Yeah, that word alone sounds pretty alarming.
It does. So let's dive in. What are our sources telling us? Let's really unpack this threat. What does doubled actually mean here?
Well, it sounds dramatic, like you said, but the key thing the sources point out is what it doubled to.
Okay.
It seems it doubled to around 2%. So, yeah, the estimate changed quite a bit, percentage-wise, but the actual probability, still very low.
Okay, right, 2%. Phew. Still low, thankfully.
Yeah.
But, I mean, the idea of a city-killing rock with, well, any chance feels a bit unsettling, doesn't it?
It does, yeah.
Yeah.
But the material makes a really important point here. Tracking these things, predicting where they'll go, it's an inexact science right now.
Huh.
Tiny changes in observations or factoring in different, gravitational pulls from planets, the sun, it can really alter the estimated orbit and therefore the impact probability.
So that 2% isn't locked in?
Not at all. They fully expect this estimate to change again. More data will come in.
Yeah, right. So it's more like a snapshot based on what we know now.
Exactly. And also putting this specific rock into the bigger picture.
Yeah.
Our sources suggest that even if it did hit, it's not thought to be anywhere near the size of the one, the dinosaur one.
Oh, the Chicxulub impactor.
Yes.
66 million years ago.
That's the one. So it gives us some scale.
That 66 million year figure. It really is a reminder of the huge timescales involved in these really major impacts. So speaking of impacts, how often does Earth actually get hit by anything? What do the sources say?
Well, almost constantly, actually. We get hit pretty much every day.
Every day?
Yeah.
But, I mean, we're not dodging space rocks walking down the street.
Right. Because, well, first, most of the planet's water, so lots hit the ocean unseen.
Okay.
And crucially, even for land hits, if the object's small enough, it just burns up. Completely or almost completely in the atmosphere, shooting stars.
Yeah.
Meteors.
Exactly. Tiny bits of cosmic dust.
Yeah.
So the daily hits are mostly, negligible. Nothing to worry about.
So the real focus is finding and tracking the bigger ones, like this one making headlines. And the sources also mention planetary defense, don't they? Is there a system ready to go if we spot a big one coming?
Well, what's interesting there is our sources explicitly say we don't have a formal ready-to-go system yet.
Oh.
However, they do mention experiments. Things have been done.
Experiments, like trying to actually do something about a threat.
Exactly, like impacting a spacecraft into a small asteroid. Remember the DART mission?
Oh, yeah. I do remember that. That showed we can physically interact with these things, potentially change their trajectory. The idea is just a tiny nudge, years in advance, so it misses Earth later on.
Okay, so we have the tech, potentially, to try and nudge one. But the sources also flag a risk with that, don't they? A complication.
Yeah, it raises this really important question about unintended consequences. The sources note that trying to deflect something isn't simple. You could potentially make things worse.
Worse? How could trying to stop it make it worse?
The main concern mentioned is fragmentation.
Fragmentation, breaking it up.
Yeah. If you hit a big one too hard, or maybe in the wrong way, you might shatter it into lots of smaller pieces.
Okay.
So instead of one object that maybe might have missed anyway or hit one spot, you could get a whole shower of fragments, spreading the risk, potentially hitting multiple areas, or even guaranteeing hits when the original might have missed.
Wow, that's really counterintuitive, isn't it? Trying to solve it could actually make it more complex, even riskier.
It really highlights how tricky this challenge is.
So, okay, wrapping up our deep dive here, the sources show. Headline-grabbing asteroid, doubled impact chance, yes, but still only about 2%.
Wow.
And that number's likely to change.
Right. And it's probably way smaller than the dinosaur killer. Daily impacts are mostly tiny things burning up.
And while there's no formal defense system yet, experiments show we could maybe intervene, nudge an asteroid.
But yeah, that intervention itself carries real risks, fragmentation being a big one mentioned. Still, the sources confirm astronomers are keeping a close eye on things.
Which leads us to a final thought for you, listening. Considering all the risks of trying to deflect an asteroid, the potential for, unintended consequences, Does knowing we could possibly intervene make you feel more secure?
Or does it raise more questions about whether we should, given the risks our sources point out?
Or maybe the fact that the last truly huge impact was 66 million years ago just tells you these catastrophic events are incredibly rare. Does that change how much you worry about this 2032 estimate at all?
Something to mull over, definitely. Drawn straight from the material we looked at today.